Hello student, this is the last topics of this chapter, that is application of logic to switching circuit. Now in this case, that is, we'll see that how the logic can be used in switching circuit. Now in these topics we shall study how the theory of the logic can be applied in the switching network. We have seen that a logical statement can be either true or false. That is, it can be true. Its truth values are either T or F. A similar situation exists in the various electrical devices also. For example, the electric switch can be on or off. In 1930, that is a Clausian, noticed an analogy between the operation of the switching circuit and the operation of logical connectives. In an electrical circuit, the switches are connected by the wire. If the switch is on, it allows the electrical current to pass through it. If the switch is off, it does not allow the electric current to pass through it. Switch is a two-state device used to control the flow of current in a circuit. Now see this here. S is a switch, L is a lamp, and the battery B. And the current is shown in a direction. In figure, we consider a circuit consisting of electrical lamp L controlled by the switch S. When the switch S is closed, that is on, the current flows in the circuit and hence the lamp glows. When the switch S is open, that means off, then the current does not flow in the circuit and subsequently the lamp does not glow. The theory of the symbolic logic can be used to represent a current by a statement pattern. Conversely, for a given statement pattern, a circuit can be constructed. That is, in the both way, the symbolic logic can be used to represent the circuit and the statement can be used to construct the circuit. Corresponding to each switch in the circuit, we take a statement letter in a statement pattern. Switches having the same state will be denoted by the same letter called the equivalent switch, and the switch having the opposite states are denoted by S and S dash. Now see this here, that is a P, the switch S1, and the negation of P is the switch S1 dash, that is its a complement. Now we don't know the actual states of the switches in the electric circuit. We consider all the possible combinations of the states of the switches in the circuit and prepare a table called input-output table, which is similar to the truth table of the corresponding statement pattern. In an input-output table, we represent one when the state of the switch is on. That is, in tables we apply the capital T, and here we will apply 1. 0 when the state of the switch is off. Now see this here. Two switches in series, that is S1 and S2. Here is a battery and the lamp. When these two switches are in a series, when we connect the two switches in a series, we apply the connective, that is AND. Here is a P and Q. And as the switches are in series, that's why we will apply here P and Q. Now for the P, just we take in a previous, that is a table, that is a TTFF. In this case we will treat as 1 1 0 0. And for the Q, we will treat at, that is a TFTF. In place of that, that is, we write here 1 0 1 0. And for the AND statement, I had given that the one key to remember, how to remember it. When both of them are true, then it is a true, otherwise false. Now in this case, when both of them are 1, then it is a 1, otherwise 0. Now here 1 and 1, that is 1. 1 and 0, that is a 0. 0, 1, 0, 0, 0, that is 0. Now every time we write for each circuit, that is a P, the switch S1, Q, the switch S2, and capital L, the lamp, capital L. Now when the two switches are in a parallel, now in this case we see that these two switches are in series. That is also we see in the physics, that is a current electricity, we say that this type of the circuit we see there. The two switches in parallel, that is the two switches S1 and S2 are connected in parallel, and electric lamp capital L is as shown in the figure. Now see this here, there is a two switches, that is a S1 and S2, they are in parallel, battery L. Now as these two switches are in parallel, therefore we'll apply here connective, that is OR, P or Q. Again same here, we'll take the values of truth values of P are 1, 1, 0, 0 and Q is 1, 0, 1, 0 and their disjunction, that is a P or Q. In this case, one of them must be 1, then it is a 1, otherwise it is a 0. 1 or 1 is 1, 1 or 0 is 1, 0, 1, 1 and 0, 0 is a 0. In this case, in this way, that is we define the two tables, that is a P and Q and P or Q. Now express the following circuit in the symbolic form of the logic and write the input-output table. That is a P, the switch S1, Q, the switch S2, L is a lamp. Now what is that? P or Q, or negation of P and negation of Q. Now in this case, we'll write here P or Q. This is the statement we have given. Now S1 and S2, these two are parallel. Therefore we write here S1 and S2. What about the next? Negation of P and negation of Q. It means that negation of P means what? S1 dash and second is S2 dash. Again they are parallel with this S1 and S2. But negation of P and negation of Q, they are in a series. Because there is AND is there and connective is there. That's why we write here S1 is a parallel to S2 and is a parallel to S1 dash and S2 dash. Now we'll construct the table. Now to construct the table, here the main joint is OR. Main joint is OR. For that we'll prepare P or Q, which is given in the column number 5. Next, negation of P, it is column number 3. Negation of Q, it is a column number 4. And using that, we'll prepare, that is OR, P or Q, or negation of P and negation of Q. That is using this. Now P is a 1, 1, 0, 0. Q is 1, 0, 1, 0. Now their negation. Negation of P is a 0, 0, 1, 1. Negation of Q is 0, 1, 0, 1. Now we want to form the P or Q. That is the disjunction. That is the P or Q. 1, 1 is 1. 1, 0 is 1. 0, 1 is 1. And last is both of them are 0. And that's why it is a 0. Next, we'll require the negation of P and negation of Q. Here both of them, here that is a column number 6. Negation of P, that is 0 and 0. It is a 0. 0, 1. 0 and 1. That is again 0. 1, 0 is again 0. But last is 1 and 1. It is 1. And lastly, we will form the disjunction between the 5 and 6. That is 1, 0 is 1. 1, 0 is 1. 1, 0 is 1. 0, 1 is 1. Hence, in this way, we can construct, that is a truth table. Also, we construct the circuit diagram by using the given statement pattern. Now we'll see the next. That is, here is this is a circuit, that is S1, S2, S1 dash and S2 dash, and the S3. Now here S1 and S2 are in a series. S1, S2, they are parallel with S1 dash and S2 dash, where S1 and S2 are in a series. Now next is, they are in a series with, this total block is in series with the S3. Let P the switch S1 is a closed, Q the switch S2 is the same, that is a closed, R the switch S3, L is the lamp, and now we'll perform the logical statement. Now how we can perform it? Now see this here. Here main joint is AND. Here is AND. It is written here is AND with R, because here is S3, and in between them, that is, we have P and Q, or in second bracket negation of P and negation of Q. And now here we'll perform the table. Now here there are the three statements, that is a P, Q, R. Therefore P is treated as 4 times 1, that is 1, 1, 1, 1. Next is 0, 0, 0, 0. What about the Q? It is 1, 1, 0, 0, 1, 1, 0, 0. It's similar to TT, double T, double F, double T, double F. For the R, we take, that is 1, 0, 1, 0, 1, 0, just like T0, TF, TF in this way. And their negation, that is the negation of P. Negation of 1 is 0 and negation of 0 is 1. In this way, we perform the column number 4. That is a 0, 0, 0, 0, 1, 1, 1, 1. It is a negation of column number 1. Now next column is column number 5. It's a negation of the column number 2. That is, it is a 0, 0, 1, 1, 0, 0, 1 and 1. Next we perform the conjunction between the column number 4 and 5. That is the AND statement, that is 0, 0, 0 and 0 is 0, 0 and 0 is again 0, 0 and 1 is 0, 0 and 1 is 0, 1 and 0 is 0, 1 and 0 is 0, 1 and 1 is 1, 1 and 1 is 1. Now next is P and Q. Now to form the P and Q, we'll apply the column number 1 and 2. The 1 and 1 is 1, 1 and 1 is 1, 1 and 0 is a 0, 1 and 0 is a 0. Next is 0 and 1 is 0, 0 and 1 is a 0, 0 and 0 is a 0, and last is also 0 and 0 is 0. Now in this way, we have performed the column number 7, that is a statement, that is a P and Q. Now next is that is a OR between the column number 6 and 7. The OR at this junction, that is 0, 1 is 1, 0, 1 is again 1, 0, 0, both of them are 0, therefore it is 0, 0, 0 is again 0, 0, 0 is again 0, 0, 0 is a 0, 1, 0 is 1, 1, 0 is 1. And now last is, that is a conjunction, that is AND between column number 8 and column number 3. That is 1 and 1 is 1. What about the next? 0 and 1 is 0, 1 and 0 is a 0, 0 and 0 is 0. Next is 1 and 0 is 0. Next is 0 and 0 is 0. But next is 7th row, that is 1 and 1 is 1. And last is, that is a 0 and 1, that is a 0. In this way, we get the truth table for the given circuit. Now the next is, in this case, that is the two switches S1 and S2. They are in parallel. Again S2 is in series, and next S3 and S1 dash, they are in a parallel. Again we write here P the switch S1, Q the switch S2, R is a switch S3, L is a lamp. Now we'll perform the statement symbolic form of the given circuit. Now what's happening here? Here is a S1 or S2, that is a P or Q. Here is a P or Q. Now it is in series with S2. Therefore we apply here the conjunction, that is AND Q. Again S2 is in series with S3 and S1 dash, which are parallel to each other. Therefore Q and in bracket R or negation of P, and in this way we get the symbolic form of the given statement, given circuit. Now we'll perform, it's a table, truth table. Now see this here, we'll write P, that is in this case, that is a P, Q, R. Then we'll form there, that is the negation of P. Next is P or Q. Next is P or negation of P. And we required here, we form the column number 7. What is the column number 7? It is a P or Q and Q. That is, we form the conjunction between the column number 5 and the column number 2. And in this way, we get the column number 7. That is the AND statement is there. That is, for example, if we see that the column number 5 and the column number 2, that is 1 and 1 is 1, 1 and for the second, that is a 1 and 1 is 1. Next is 0 and 1 is 0, 0 and 1 is 0, 1 and 1 is 1, 1 and 1 is 1, and the remaining both of them are 0. And then now the last column. In the last column and between the 6 and 7, 1 and 1 is 1, 0 and 1 is 0, 1 and 0 is 0, 0 and 0 is 0, 1 and 1 is 1, 1 and 1 is 1, 1 and 0 is 0, 1 and 0 is 0. And in this way, we have performed the truth table for the given circuit. Now the next is construct the switching circuit of the following. Now in this case, now see this here, P or in bracket negation of P and Q, or in next bracket negation of Q and R bracket complete, or negation of P. Now what is the main joint here? Here is the OR is. Now P the switch S1, Q the switch S2, R is the switch S3. Now the first is that is the, this is the P. P is OR with, it is in a parallel with negation of P and Q. This is S1 dash and S2. And again it is a OR with. It is a OR with, that is a negation of Q and R. That is a S1, S2 dash and S3. And again OR with, this is the negation of S1 dash. This is the logical circuit for the first one. Now the next is P is the switch S1, Q is the switch S2, and R is the switch S3. That is a regular we will write for every questions this. Now in this case, now see this here, P and Q and R, or is a main joint here. And the next is that is a P means what? S1, S2 and S3. All are in AND. They are joined by the AND, conjunction AND. Therefore all are in a series. They are parallel with the P. P means what? It is S1. And again they are parallel with Q and negation of the R. Q means what? S2. And negation of R is a S3 dash. And this is the battery and the L. In this way we have performed the circuit diagram for the given statement pattern. It's very simple again. P and Q and R, they are in a series, or they are parallel with the P means S1. Again they are parallel with the Q and negation of R, but the Q and negation of R in a series, that is the S2 and S3 dash. Next is third, that is a P and R, or negation of P and negation of R, or negation of P and negation of R. Now see this here, P and R. Now P and R means what? S1 and S3, they are in a series. Or negation of Q and negation of R, that is S2 dash and S3 dash. Again, they are in a series. Now, or negation of P and negation of R, that is S1 dash and S3 dash. Now, here is or they are in a parallel way, have the joint there. Therefore, this is a statement pattern and this is the circuit for this statement pattern. Now, the next question is, give an alternative arrangement for the following circuit so that the new circuit has a minimum switches. Now see this, in this case the switches are S1, S2 dash, S1 dash, S2, S1 dash and S2 dash. These are the switches, that is the total switches are the 6 switches are there with their complement. Now here P, that is the switch S1, Q the switch S2. Now the symbolic form. What will the symbolic form? That is a P and negation of Q, or negation of P and Q, or negation of P and negation of Q. Now see this here, P and negation of Q, P and negation of Q. Next is or negation of P and Q, or last is, that is the negation of P and negation of Q. This is the, now we will perform here, that is we want to minimize the switches. Now how we can minimize the switches? It's very again interesting. That is, if you know the algebra of all the laws there, that is, we have seen that the algebra of the statement. In that we have seen that this is, that is a P and negation Q, or negation of P and Q, or negation of P and negation of Q. Now first is, see this here, P and negation Q. Now if we see this, that is the negation of P is here, negation of P is also here. That is, we will collect these two brackets. That is, in square bracket, negation of P and Q, or negation of P and negation of Q. Next, now see this here, that is the negation of P is distributed. Negation of P is distributed for these two brackets by using the operation AND. That is a P, negation of P and negation of P and, therefore negation of P and in bracket Q, or negation of Q. That is the AND is distributed over the OR, AND is distributed over the OR. That is the negation of P is distributed over the OR. That's why negation of P and in bracket Q and negation of Q. This is the distributive law. Now next is a Q or negation Q. Suppose Q is a T, its a negation will be F. But what is a T or F? Is a T. Therefore, this is the complement law. We apply here and write there. That is the negation of P and T. But what will the answer from these two? Here is a conjunction. Now we don't know the negation of P, but this is a true. When this statement will be, it's a truth value depends only on the negation of P, and this is called the identity law. Therefore, this bracket is as it is. Therefore, we have, that is a P and negation of Q or negation of P. Now we can write this like this, and it is called the commutative law. Therefore, it is a negation of P or in next bracket P and negation Q. Now next, this negation of P is distributed over the AND. Therefore, it is written as negation of P or P and this and is here, negation of P or negation of Q. Now negation of P or Q, this is again nothing but the T. Suppose this is the F, then this will be the T. What is the T or F? Is it T? And therefore, now next. Again the same condition is here. There is a T and negation of P or negation of Q. This is the law of the complement. And what about here? Now again the truth value of this depends on this bracket, and therefore it's called the identity law, and that's why we get negation of P or negation of Q. Instead of all these switches, we have only the two switches, and they are, what are they? That is a negation of P or negation of Q. It means that they are in parallel and they are there. That is S1 dash and S2 dash. They are in a parallel. That is the switches are the minimize. Now see this, how many switches were there? There is a total 6 switches. Out of the 6 switches, we can minimize up to the 2. Now the next question. Express the following switching circuit in the symbolic form of the logic. Construct the switching table and interpret it. By using this switching circuit, we want to construct the logical statement. Now what's happening here? This is a P, Q, negation of P, negation of Q. These two are in a parallel. This is in series with this block S1 or S2. S1 dash is in series with this S2. It means that 1, 2, 3. These are joined by the AND statement. Now see this here. P the switch S1, Q the switch S2, the symbolic form. Now see this. This is a P or Q and negation of P and negation of Q. This is the symbolic form of the given circuit. It's very simple. P or Q and negation of P and negation of Q. Now in this case, we'll perform the table, switching table. That is we required. That is a P, Q, negation of P, negation of Q. We'll find out their disjunction. Next we find out P or Q and negation of P. And lastly, P or Q and negation of P and negation of Q. Now the first is 1, 1, 0, 0, 1, 0, 1, 0. Negation of P, that is a 0, 0, 1, 1. Negation of Q is 0, 1, 0, 1. P or Q is 1, 1, 1, 0. Next is AND between 5 and 3. That is a 0 and 1 is 0, 0 and 1 is 0, 1 and 1 is 1, 1 and 0 is 0. And last is, it's a AND with the negation of the Q. That is a 6 and 4. And AND statement, that is a 0, 0, 0. 0 and 0 is 0. Next is 0 and 1 is again 0. 1 and 0 is 0. It means that all are 0. The last column contains all 0. The lamp will not glow irrespective of the whatever the status of the switches. The lamp will not glow. This is interpretation of the given circuit. Now the next is a simplify the given circuit by writing its logical expression. Also write your conclusion. Now see this in this circuit. This is S1. S1 dash and S2 dash, these are in parallel. Again, it is in with the series with the S2. Now P the switch S1, Q the switch S2. The logical expression. Now this is a P. They are in series with this block. Yes. It's AND. S1 dash, S2 dash, they are in parallel. Therefore, it is a negation of P or negation of Q. And again in series with the S2 and Q. Now see this here. Consider this statement P and negation of P or negation of Q and Q. Now, by using the associative law, we can write here P and negation of P and negation of Q and Q. This is associative law. Now see this in this case. That is, this P is distributed over the R. That's a P and negation of P. Next, P and negation of Q In between them, here is OR, here is OR. Now what is the P and negation of P? P, if you take that this is the complement law. P and negation of P is F. So this is true, this is a false. P and F is always F. Therefore, this is F. Now next is OR P and negation of Q and Q. Now next is by using the identity law. This is OR statement between them. Its truth value depends on this P and negation of Q. And this is Q. This is identity law. Next we can write it like this by the associative law. Here is operation and here is also operation, and therefore we will apply here the associative law. We shift the bracket, that is a P and negation of Q and Q. Now what is the negation of Q and Q? It is again F by using the complement law. If you take the T, this is the T, then this will be the F, and there the AND is, that is the F. Therefore by using the complement law we have that. Now next is a P and F. Whatever the value of this P, the definitely 101%, its a truth value is F. This is the identity, and our conclusion that the lamp will not glow whatever the irrespective status of the given switches, if you have this type of the arrangement. Now the next is example number 6. In the following switching circuit, write the symbolic form. Second, construct the switching table, and last, simplify the circuit. Now see this circuit S1, S2, they are in series, they are parallel, S1 dash and S2, they are parallel with S1, S2, again they are parallel with S3 and S2 dash. Now P, the switch S1, Q, the switch S2, R, the switch S3. Now next, we'll write here their symbolic form of the given circuit. P and Q, or negation of P and Q, or R and negation of Q. This is in the form. Now next is we perform, it's a truth table. Now see this truth table, that is a P. We first write the PQR. Next we require the negation of P, negation of Q. Then find out its values. That is a P or Q is here. P and Q. Now I will not repeat again this whole table. Write down the P 4140 1100, R is 1010 in this way, and we can write these all. Next is negation of Q and between first and second. Now next is negation of P and Q, that is the and between 4 and 2. Next is 8-1. What is that? That is the and between third and fifth. And last is a or between these two, 6, 7 and 8. That's we get like this statement pattern. Now next is, this is a truth table. You can perform this. Now this is important. Now this is a statement pattern P and Q, or negation of P and Q, or R and negation Q. Now see this here, which is common here. Now Q is common here for these two brackets, P and Q, or negation of P and Q. That is a and is distributed over the R. That is an Q is a distributed over the R. Therefore, this is written as by using the distributive law P or negation of P and Q. That is and is distributed over the R here. Therefore, it is written as distributed by using the distributive law. Now, what is a P or negation of P? Here, negation of P is a T. T and Q. That is, there is a complement law. And keep this as it is, that is R and negation of Q. Now next is T and Q. T and Q by using the identity law. It depends on the Q, value of the Q. Therefore here is a Q, or in bracket Q and negation of Q by using the identity law. Now this Q is a distributed over this bracket. that is a Q or R and Q or negation of Q, and between these two, that is or is distributed over the and, Q or R and Q or negation of Q. Now Q and negation of Q is again the T by using the complement law. Now again, what is happening? Q or R and T. Again by the identity law, the value of this statement depends on Q or R. It is a Q or R. It is a simplified circuit. Therefore, what is the simplified circuit? This is the S2 and this is S3. Both are in parallel. Therefore, the simplified circuit is S2 and S2 is a parallel to S3. This is the simplified circuit. And in this way, we have completed all the solved examples of this. Now we'll start the exercise 1.5. Now exercise 1.5. Express the following circuit in the symbolic form of the logic and write input-output table. Now this is a circuit. S1 is a parallel with S2 and S3. P, for all problems, this we will write here. Somewhere I will not write here. You can consider this. Here is a switch. S1 is a parallel with the S2 and S3, where S2 and S3 they are in parallel. P, the switch S1 is a closed. Q, the switch S2 is a closed. R is the switch S3 is a closed. L is a lamp that closed. Now the symbolic form of the given circuit is P or in bracket Q and R, that is equals to L. Now we'll write here, that is a PQR. Therefore the first is PQR. Now we'll require Q and R. Therefore we'll write here Q and R. And again it is with the disjunction with the P. That we'll find out the disjunction between column number first and the column number 4. Now the P is 1 1 1 1 0 0 0 0. Q is 1 1 0 0 1 1 0 0. What about R? 1 0 1 0 1 0 and 1 0. Now Q and R, that is and between these two, 1 and 1 is 1, 1 0 is 0, 0 1 is 0, 0 0 is 0. Because and statement required, both of them must be 1, then it is 1. Therefore, here both of them are 1, therefore it is 1. Next is, here both of them are 1, therefore it is 1. Here, now in other places, other than these two places, that is row number 1 and row number 5. That is a row number 1 and row number 5. That is, there is 1, otherwise it is a 0. Now the next is a disjunction between the column number 4 and 1. That is 1 and 1 is 1, 1 0 is 1, 1 0 is again 1, 1 0 is 1, 0 1 is 1. Now next is 0 or 0 is 0, 0 or 0 is 0, 0 or 0 is a 0. And that's why we get this table. Now the next is question number 2 for this circuit. Again the same dialogues are there. P, Q, negation of P, that is the switch S1 is closed, or the switch S1 is open. This also we can write. Negation of Q, the switch S2 is closed, or the switch S2 is open. This we will write for every problem. Now S1 dash and S2 they are in a series, and S1 dash and S2 they are parallel with the S1 and S2 dash which are in the series. Now we will perform the symbolic form of the given circuit. Now S1 dash means what? Negation of P and Q, or P and negation Q, that is equals to L. Therefore we perform this table, that is a truth table for this. Now only the two statements are there. Now we'll require the P, Q, negation of P, negation of Q, negation of P and Q, P and negation Q, and the disjunction between the column number 5 and the column number 7. Now first is P is 1 1 0 0, Q is 1 0 1 0, and the negation of P is a 0 0 1 1, negation of Q 0 1 0 1. Now next is a negation of P and Q, negation of P and Q, that is a 0. Next is a negation of P and Q. Again This is 0. Next is 1 and again 0. Next is a P and negation Q. P and negation Q, that is 1 0 is 0. Next is 1 1 is 1. 0 0 is 0 and 0 1 is a 0. Now the disjunction between the column number 5 and the column number 6, 0 or 0 is 0, 0 or 1 is 1, 1 or 0 is 1, 0 or 0 is 0, and in this way we get the truth table. Now the next is third. Now the S1 is a series with the S2 dash and S3 which are in a parallel. Again S1 and which are in series with the S2 dash and S3. This block is a parallel with S2 dash and S3. Therefore, we will perform the symbolic form of the given circuit. Now see this here. This is the P, and because they are in series with S2 dash, this is the S2 dash, or S3 means what R. Now this is a parallel with these two, which are S2 dash and S3 dash. Therefore, we write here or negation of Q and negation of R. Now we will perform here the table. Now see this, for this table we will require PQR. Next is we will require the negation of Q, negation of that is I had find out the negation of Q also. And in this way we will perform that table that's we required here. That is, we do not require the column number 4, but I had performed it, so it doesn't matter. Next is negation of Q, negation of R. Then we require the negation of Q or R. Here is a column number 7, negation of Q or R. And then we perform the column number 9, which is P and negation of Q or R. That is the and between the column number 1 and the column number 7. And next is a negation of Q and negation of R. Negation of Q and negation of, that is the AND statement between the column number 5 and 6, which is the column number 8. And using this, that is, we will perform, that is a AND between or between the column number 8 and the column number 9, or between the column number 8 and column number 9. And in this way, we will get the truth table. Now you can perform this truth table. Okay. You can write down this truth table. Now the next question is with this big one truth table. Now the fourth is again, what's happening here? That is a logical statement for this given circuit. Now what's happening? S1 and S2. Again the same statements are P, S1 is closed, Q, S2 is closed, R, S3 is closed, and their negation, that is a S1 is closed according to their. S1 and S2, these are in parallel, therefore P or Q. Again they are series with the S2 and Q. Again they are in series with the S2, S3 and S1 dash. That is the negation of P or R. And again perform the truth table for this also. Can perform the same things here. That is the statements are, what is the truth table? First we will write PQR, then we will require the negation of P, then we will require the P or Q. Here is the column number 5, which is P or Q. Next is the column number 6, which is the R or negation of P. Then we will form, that is a now perform the AND between, which are they? That is AND between the column number 5, column number 2 and the column number 6. 2, 5, 6. For example, we'll take the single one. 2, 5, 6. Here is the first row. That is 1, 1 and 1. All are 1. That is therefore it is 1. Next is 1, 0, 1 and 0, therefore it is a 0. And in this way, we will perform the column number 7 by using the disjunction, that is by using the conjunction, that is a and statement between. You can perform this type of the table. Now the next is number 5. Now see this, the circuit, that is S1 is a parallel to S1 dash and S2 dash, S1 dash and which are in a series. Again, these two are again a parallel with the third one, that is S1 and S2. Therefore, the statement pattern is a P or negation of P and negation of Q, or P and Q. And in this way, P switch S1 is closed, Q switch S2 is a closed, negation of the negation of Q. We can write it. And now see this here. What we require here for this statement pattern, we'll require the negation of P, negation of Q. Then we'll require the AND between negation of P and negation of Q. And between P and Q. Now see this here. There's a P, Q, negation of P, negation of Q. And between the 1 and 2. And between 1 and 2. I will not repeat again here. Next is that is a negation, and that is and between the column number 3 and 4. This is here. And the or between which column? That is a column number 1, column number 5, and the column number 6. This is the or statement in between them. That is a 1, 5, 6. Now we'll check one of them. The first is 1, or 1, or 0 is 1. And the next is 1, 0, or 0 is again 1. What about here we get the 0? We'll check here. 1, that is the 0, 0 and 0 is a 0. And in this way, we can get the truth table for the given circuit. Now the next is, this is the circuit. That is S1 and S2, they are in parallel. Again, they are in series with S2 and S3, which are in parallel. Again, they are in series with the S3 and S1, which are in a parallel. There is a P or Q, and Q or R, and R or P. Now in this case, PQ, P or Q, and Q or R, and P or R. Now what is it? And between these two? These all three. Therefore, we will write here. First is PQR. It's very simple. Next is find out or between them. Next, find out the or between 1 and 2, or between 2 and 3, or between 1 and 3. That is it. And the and between these 4, 5, 6. That is and between. We'll check here. 1, 1, 1. That is and is 1. 1, 1, 1. It's 1. 1, 1, 1. It is 1. What about here 0? 1, 0, 1. Yes. Next is 1. This is clear. All this table is very clear. You can write down this table. Now the next question number 2. Construct the switching circuit of the following. The first is negation of P and Q, or P and negation of R. Now P the switch S1 is a closed, Q the switch S2 is a closed, R the switch S3 is a closed. And their negations, that's the statement. This is the, for the first example, it is a true for all the examples. Now the switches. Now what is that? Negation of P and Q. Negation of P, that is S1 dash S2. They are in a series. Next is they are in a parallel with P and negation of R. That is a S1 and S3 dash. This is the circuit. In this way, negation of P and Q, or P and negation of R. And in this way, we get the circuit. It's very simple. We can perform it. Now the next is P and Q, or negation of P and in bracket negation of Q or P or R. Now first is P and Q, that is S1 and S2. They are in series. Again they are in parallel with this total block. This is in a square bracket. How they are? Negation of P. This is S1 dash. And they are in series with negation of Q. Means what? S2 dash. They are parallel with the P. Means what? S1. It's a parallel with R. Means what? S3. Once again I will repeat here. P and Q. S1, S2. Or it's a parallel with this total block, which is S1 dash, and in series with the negation of Q, means what? S2 dash, S1 and S3, and in this way we have the circuit diagram for the given statement pattern. Now the next is P or Q, or negation of Q and negation of R, and negation of P and negation of R. Now see this here. We required the three switches. First is P or Q. Sorry, P and R means what? S1, S3. They are in a parallel with negation of S2, negation of S2, that is S2 dash, and S3 dash. They are in a series. Now these two are in a parallel, and these two are in a series, that is S1 dash and S3 dash. In this way we get the circuit diagram. Again I will repeat here. This is R between these two. This is one and this is second one. Now this block is in series with this statement, that is the negation of P and negation of R, and in this way we get the circuit diagram for the given statement pattern. Now the next is P and negation of Q and R, or P and negation of Q or negation of R. Now see this here. First is OR, means what? This is the disjunction between these two. First block and second, that is S1, S2 dash and S3. Next is P and negation of Q or negation of R, that is S2 dash and S3 dash, and in this way we get the circuit diagram for the given statement pattern. Again this is OR, means these two are. This is the first block and this is the second block. Now next is P and negation of P or negation of Q or P and Q. Now the first is S1 is parallel to S1 dash, is parallel to S2 dash, which is again parallel to P and Q, that is S1 and S2. And this is the total circuit diagram for the given statement pattern. Now the next is sixth one, that is a P and Q or negation of P or P and negation of Q. Now first is P and Q. This is S1 and S2. They are in a series. Again it is a parallel with the negation of P, means what? S1 dash. Again they are in a parallel with S1 and S2 dash, which are in a series. Means what here? Disjunction, disjunction, parallel. These are parallel. These are in the series. These two are in a series. And in this way we have the circuit diagram for the given statement pattern. Now the next is give an alternative equivalent simple circuit for the following circuit. Now again the regular terms, they have the regular meaning P, the switch S1 is closed, Q, the switch S2 is closed. Now see this is the circuit diagram. It's very simple. S1 is in series with S1 dash is parallel to S2. Therefore we will write here the logical statement pattern. The logical expression for the given circuit is P and negation of P or Q. Now we will solve this statement. Now see this here, P and negation of P or Q. Now here and is distributed over the R. That is a P and negation of P or P and Q. This is the distributive law. Now see this first. P and negation of P. P and negation, if we take the P as a true, therefore by the complement law, this is the F. F or P and Q. But what is the, by the identity law, it is a P and Q. Now instead of how many switches are there? 3 switches. We can apply only the 2 switches which are in the series where the P and Q, this is S1 and S2, and in this way we have simplified the given circuit diagram. Now the next second, now in this case, see this here, this is S1 is in series with the S2 and S3. This total block is parallel with the S3 dash, S2 dash, S1, which are in a series. Now we can write the statement pattern. Now see this here, this is a P and S2 and S3, they are in a parallel, or this block, total block is parallel with this block, which are in a series, but it is a negation of R and negation of Q and P. Now we can write it as, now we'll simplify the above expression as follows. Now write down here, P and Q are R, or negation of R and negation of Q and P. Now by using the De Morgan's law. Now what is De Morgan's law? That is, we take the negation as a common in the mice. That we can write here. By using the De Morgan's law, like that is the P and Q are R, or by using the De Morgan's law, that is the negation, this and will become R. That is the negation of R or Q and P as it is. Okay. Now the next is, this is the P and Q or R and negation of Q or R. This is the commutative law. That here is R or Q. It is written as Q or R by using the commutative law. Again, if we see this, that is a P and Q or R, or it is written as like this, again by using the commutative law. Here is a P and negation of Q in bracket Q or R. Now if we see this, the statement pattern, what's the common here? These two, this is the one block and this is another square bracket. Now P is a common there, and what is the different one? Q or R and the negation of Q or R. Therefore by using the distributive law, that is a P is distributed over these two. P is distributed over the R, that is a P and in bracket Q or R, or negation of in bracket Q or R. This is by using the distributive law. Now what is the value of this? This by using the complement law. The value of this is a T, and P and T, it depends on the P. That is using the identity law. Therefore, the simplified circuit contains only the single switch. This is a simplified circuit. Now see. Now the next is question number 4. Write the symbolic form of the following switching circuit. Construct the switching table and interpret it. Now the symbolic form, S1, S2 dash, S1 dash and S2, they are in a parallel. Again P, Q are same dialogues are here. Now see this here, P or negation of Q or negation of P and Q. Now we'll write here the statement pattern. Now write is P, Q, negation of P, negation of Q, or between P or negation Q, and next is a or between negation of P or Q, and between the column number 5 and the column number 6. Now we'll interpret the result, that is in this case What is the last column? It represents 1, 1, 1. That is, a lamp will glow irrespective of the status of the switches. Whatever that, lamp will glow by using the switch diagram. Now the next is second one. For the second, symbolic form is, what is the first? S1 is a parallel with S1 dash and S2 dash, which are in series. Again, they are in parallel with the S1 and S2. Therefore, the P first is or negation of P and negation of Q. And again, they are in or disjunction with P and Q. This is. Now, perform the truth table here. We'll perform the truth table. Now, see this here. The truth table. First is P, Q, their negation. Okay. And the next negation of P and negation of Q. Then again or with P or negation of P and negation Q. Next we'll find out the P and Q. And that is the or between the column number 6 and the column number 7. And in this way we will perform the table. 1, 1, 0, 0, 1, 0, 1, 0, their negation 0, 0, 1, 1, 0, 1, 0, 1. And in this way we know now what's the meaning of this and or. In this way the table is performed. Now see this here. In the last column, here is a light will glow, and here it is not possible. That is when the switch. What about there? The lamp will not glow when the S1, this is the S1, when S1 is off and S2 is on, otherwise it will glow, because here we get the 0, that is the light is not glow. But when this is a S1 and S2, S1 is off, S2 is on, at that time the light will not glow. Now the next is, again see this here, statement pattern. Next is third one, the symbolic form of the given circuit is S1, S2 dash, S3 dash. They are in parallel. Again they are in series with the S1 and S2 and S3. That is a P or negation of Q or negation of R. And P or in bracket Q and R. Now we'll perform this truth table. For this we'll require the PQR. For that, first is PQR, their negation of P, negation of Q, negation of R, and or between the column number 1, 4 and 5. You can perform the or. Okay. Next is or and between the column number 2 and 3, which is the column number 7, and again it is a or between, that is the column number 1 and 7, that is the or between 1 and 7, you will get the column number 8. And in this way the column by using the column number 6 and the column number 8, perform the AND statement, and you will get that is the, which is the, that is 1, 1, 1, 1, 0, 0, 0, 0, and this is nothing but the switch S1, and therefore the lamp will glow if S1 is on and any status of the S2, whatever that S2, the lamp will glow. It depends on only the S1. If switch S1 is on, the lamp will glow, because this is the total P is here. Now the next is problem number 5. Obtain the simple logical expression of the following. Draw the corresponding switching circuit. Now the first is P or in bracket Q and negation of Q. If you write here Q and negation by using the complement law, Q and negation of Q is F. P or F is again P by using the identity law, that is equals to P. Therefore the single switch we will require here for this logical circuit, and therefore where this is the simplified circuit. Now the next is, it's very simple. Next, that is the negation of P and Q, or negation of P and negation Q, or P and negation Q. Now see this or and or. But before that, we'll see this first two bracket. Here is a negation of P and here is also negation of P. That is the negation of P is distributed over the or. Now this is, I say here it is over the or. That is the negation of P is distributed over this or. That is what is the sign between these two brackets is or. Therefore, I say that the negation of P is distributed over the or. Therefore, negation of P and in bracket Q, or negation of Q, or P and negation Q as it is. Therefore, this is the distributive law. Negation of Q is distributed over the R. Now, what is the value of Q or negation of Q by using the complement law? It is a T. And next is a negation of P and T. By using the identity law, it depends on the value of the P. Therefore, it is a negation of P or P and negation Q. Now, next is this negation P is distributed over the AND. That is the negation of P or P and negation of P or negation of Q. Now, what is the value of negation of P or P? It's a T by using the complement law. Now, the next is now the T and negation of P or negation of Q. This bracket, it's a truth value is a negation of P or negation of Q by using the identity law. It means that these two switches must be the parallel, that is S1 dash and S2 dash are the parallel. This is the simplified circuit. Now the next is problem number 3. There is a P or is another square bracket negation of Q or negation of R. That is the bracket complete, or P or in next bracket Q and R. Now see this here. These two brackets are using the De Morgan's law. That is, it is written as negation of P or. What's the change in here? By using the De Morgan's law, negation of Q and R, and P or Q and R by using the De Morgan's law. Now in this case, this P, here is a P is common. That is a P is distributed. P is distributed over the AND. Therefore, it is a P or in next bracket negation of in bracket Q and R and Q and R. This is the distributive law. And therefore, what's the value of this? By using the complement law, it is F, because negation of Q and R and Q and R, it's a F. Therefore, P or F is again P. Therefore, only switch S1 is required here. Next is now this problem is modified. This is the last problem of this exercise. I had modified here. I had added the one extra term because there is not answer given in the textbook also. That is we have P and Q and negation of P, or negation of P, Q and R, or this I had added extra, or P and negation of Q and R. This is a true, ये correct है क्या, बराबर है. I had added this. ते बरोबर आहे का चूक आहे, पण मी तिथे ऍड केलेलं आहे. तुम्हाला जर ते लिहायचं असेल तर तुम्ही ते लिहू शकता. Otherwise, keep aside, you solve yourself. But I think that the problem should be like this, because answer given in the textbook is not, again, it's not written in proper way. Okay, therefore I had written here problem is modified. I had written here this extra. Now see this here. The first is P and Q and negation of P, or negation of P and Q and R, or P and Q and R, or P negation of Q and R. Now in these two statements, that is by using the commutative law, it's written as like this. First is and P and negation of P and Q, negation of P and Q and R, or P and Q and R, or P and Q and R. That's a commutative law. It's applied here. Now P and negation of P, it's F. Okay, that is a complement law, and the other brackets are as it is here, which are negation of P, Q and R, or P, Q, R, or P negation Q and R by using the complement law. Now again F and Q. Now by using the identity law, F and Q is definitely F, or this bracket, that is the negation of P and Q and R, or P and Q and R, or P and negation Q and R by using the identity law. Now its value depends on this whole bracket, three brackets, that is the negation of P, and here that is, it is written as in this manner, that is the negation of P and Q and R, or P and Q and R. Now see this here, this bracket is also as it is. Now Q and R, here is a Q and R, that is a negation, that is a Q and R is distributed over this R, which is in between negation of P or P. That is the Q and R is distributed over the and, that is Q or. That is the negation of P or P and Q and R. This is the distributive law. I had underlined here. This is a distributive. Next is now what is the value of negation of P or P? Negation of P or P is a T by using the complement law. Now these two brackets are as it is. Now next is a T and in bracket Q and R. Now the value of this bracket is again Q and R by using the identity law. Now next is this is, that is a Q. We can write this bracket as it is, that is a Q and R, or P and negation of Q and R, that is, it is written as like this by using the distributive law. It's written as, in this case, this R and this is R. This R is distributed over these two, which are to Q and P and negation Q. Therefore, it is written as P or in bracket P and negation Q. This R is distributed over the R. Therefore, it is written as Q or in bracket Q and negation of Q and R. This is by using the distributive law. R is common for these two brackets. It is distributed over these two brackets. Now the next is, again, it's written as this Q is distributed over these two. That is a P and negation of Q. Therefore, it is written as P or Q and Q or negation of Q, and this and R as it is by using the distributive law. Again, what is the value of Q or negation of Q? Q or negation of Q is a T. Q or P and T by using the complement law. The value of the Q or negation of Q is a T by using the complement law. And next is a Q or P and T, bracket complete, and R. Next is a Q or P and R by using the identity law. The value of this bracket, it depends on Q or P. Therefore, by using the identity law, Q or P and R. And finally, it is written as P or Q and R by using the commutative law. It is written as P or Q means what? P. Q or P means what? P or Q. Bracket complete and R. And in this way, we have completed the exercise 1.5. Now we'll see in the next video. Till then, goodbye.